So, welcome to the challenge track this Wednesday. You might know me, I'm Sampo from yesterday. Some practical information. When we are today on Wednesday, the main hall is used for one of the tracks. So from here, if you want to get coffee or something, you can access the kitchen from the back. So maybe from the front you might not, well, you can probably from the lower side and from the back you can also access the kitchen, but still, like, just beware that the routes you may used yesterday may not be cleared today. I'm chairing this session today, and we have both the challenge presentations as well as some other presentations on this track as well. The track is being videoed, mostly because this is something new for Inspire, having data challenges. So we feel that it's important to get these for later on for reviewing. And especially I feel like this should be maybe a part of the upcoming Inspire conferences as well, to have data users and try to get data users on board. And of course my laptop has died. So yes, welcome. The agenda, as I mentioned, we have the challenge presentations. We have, in this first slot, I will be presenting not a challenge, but something else, automated publishing of Inspire data using cloud. Then we will have Bas Boys and Bart Monet, the painter. Yes, you will see Bart Monet, the painter, doing the team Rather Wet from Sweat from Holland. Then we have a coffee break. Then we will have the Helcom challenges, Team Deep Space and Team Statistics Finland. Deep Space is still in deep space, but I'm sure they will get here. And then after lunch, we will have the final challenges, the Safe Software and Minerva for JRC's challenge. And after that, we have the launch of the Inspire Community Forum. And then after the last coffee break, there's a workshop in experiences in implementing pan-European services using national Inspire services. So it's a bit of a mix of both. As I mentioned yesterday, not all of the challenge teams came out alive. some did not come to the finish line, so we've made this session a bit of a mix of both. So to start, my presentation on automating Inspire services. This is a bit of a special case that we did, but we found this to be a very effective way of publishing data on a tight time schedule, but also making something which is quite robust and scalable using cloud. So we thought that this could be interesting for a more technical audience and maybe even a wider audience to hear. So just a quick reminder on Spatineo, we have monitor, we have performance, we do quality assurance of spatial web services, and as well as analytics, so Google Analytics for spatial web services. But we also do a lot of services. We do many different types of projects. We work on software, GIS, we work on machine learning, but also impact analysis and economical benefit analysis. So we have a wide array of different services. That's why I'm presenting this. This was a case that we did for the Ministry of Environment, like one block away from here. They are in the process of renewing the land use planning in Finland. Most of the municipalities, if not all, use highly software-assisted processes to develop the land use plans. But unfortunately, there's no data model for the land use plans. We're still living in the age where the land use plan is just a picture. This is probably very typical for many of you. And now they are in the process of figuring out how to do this digitally, to get a national data format which is Inspire compliant, but which also works for all the parties who are producing the plans, who are using the plans for statistics purposes and so on. And we've been assisting them with this project for quite a while now. And this project was part of the National Geospatial Platform Project, which is presented at one of the stands in the main hall. You heard about it from yesterday. Basically, the idea is to harmonize and improve e-services in public administration, get better quality data, more transparency, cost savings for public administrations in the sense that they can use the platform instead of setting up their own infrastructure, especially important for small municipalities. So this was a perfect case for developing of the digital spatial planning. That's why they were working on it, working with them So basically, just to give a quick pitch to them, this is like the architecture of what they're doing. Up on top are the data producers, for example, municipalities in this case. They have an upload service where these parties upload the data in a harmonized format or a non-harmonized format. They have a quality guard service which checks the information against different validation rules and sends reports to the data creators that helps them to improve the quality of the data. This is a really important step because when you're gathering this national database, you want to ensure that it's not just fitting into the data model, but it's actually good quality information, and it's that it's in line with the other pieces of information in the database as well. They go into a sort of temporary loading database, and then there's lifecycle management processes which will bring this all together. So do change management, work with unique identifiers, make sure that things are not duplicates, and if something is updated, there's a historical record of what it was before and so on. And then they are providing a number of services from this national database. One interesting is this change set subscription service, which they are still developing, but it's an interesting format where a lot of use cases unfortunately still require the data user to have the complete copy of the data. But they can't make a complete copy every day or every hour. So using the change subscription service, then they get notified when something changes in the interesting data set, and then they can just download the part which was missing and then get notified when the next change comes in. So it allows for real-time synchronization of these complex features. And then of course there's download services, there's view services. But for this project that we were working on with the Ministry of Environment, there was a big conflict in scheduling and priorities. So whereas in the Geospatial Platform Project, they were really focused and still are on the data input side and data quality. This is really important. But the pilot project, they required services, they required data. They had the input done, they wanted the data out, they wanted to use the data to see what happens then. In the Geospatial platform is a huge project with a lot of parties interconnected. They can't just like make changes quickly. They're not agile. They have a fixed schedule of releases that they're working on, while as the pilot project we're like, yeah, we have 6 weeks. and that was definitely a problem for them. Also, the platform is trying to be generic, which makes things slower. It takes time to develop something which works for all use cases, where the pilot project had very specific requirement, very specific use cases or partial use cases that they wanted to try out, and they needed it ASAP. And also the Geospatial platform is looking forward, which is really good. They're looking into OGC API, they're looking at symbol features, while working on for the land use model. The land use is not a simple feature, it's a complex thing. You need support for complex features, and also the client support is not there for the newer services. So we needed something which was the current version WFS2 with a GML Inspire data models. So basically, we took out the services, or in this project, we didn't care about the services provided by the platform. Instead, we got an extract from the national database, and then we provided the services using using cloud. And basically what it looks like on a very technical level, now we deep dive into how Amazon works. But what we did was that we had a repository in GitHub, a GeoServer configuration. And then we had an Amazon S3 setup, where every time the data set changes on the National Geo platform, they send the new database dump into S3, which launches an automatic process on our side, or well, we configured it, but it's running on Amazon, where it takes the source, it builds a PostGIS database, makes a Docker container out of it, it puts it into ECR, which is a Docker registry inside AWS, and then it launches what's called a task in Fargate. Fargate is a system which is used to have containers work together and to set up containers together. And then the same for the GeoServer. So there's a lot of configuration for these layers. that is required for us to use that post-GIS dump to provide the Inspire services, to provide the national data model and so on. So that was also developed. And every time a commit was pushed to Git, as to say files were changed, the configuration was changed, this pipeline went into action. It automatically took GeoServer, built only the parts that were required, took our configuration and deployed it and sent out the Fargate task. Then the Fargate task basically runs up a new post-GIS, runs a new GeoServer, and then there's a system which checks, does it work? Does it work? Does it? Okay, now it works. And then it switches the load balancer, which you can see on the right, to use the new task, and then the old task dies off. So it's a seamless update. No one sees anything. It just magically updates, and there's no service breaks or anything like this. And the beauty of one beautiful thing here is, from a technical point of view, are these CloudFormation scripts. So basically, instead of us saying to AWS, do this and then do that, oh, sorry, I forgot, destroy that thing and replace it with this, we created this sort of script, or it's kind of like a template. It says that I want to have this. I want to have 2 servers, and I want to have 1 load balancer, and I want to have this and this and this. And what AWS allows you to do is, if you change something in this script, you can say to AWS, okay, I want to update this stack. And it looks at, okay, this is what's running, this is what they say that they need. Okay, that has changed. So it switches that. So it only makes the changes that are required for the stack to update to the current version. So this is a really, really handy way of handling infrastructure. So basically you can write a document which says, I need this sort of infrastructure, and then you make changes to it, and immediately, or so almost magically, everything works. Of course, everything works is something that IT people say often. It always comes with the asterisk that you saw in Bart's slides yesterday. There are, of course, caveats. It's not perfect, but it's very near perfect. Especially with a system like this, as you saw from the picture, it's doing the end result is somewhat simple, but to get there, to have everything, have the automation working seamlessly, it takes quite a bit of configuration, and we didn't write it once. We wrote it like 100 times to get it working properly. So for the PostGIS, like I said, the code pipeline, it builds a Docker image, so that's for a container, which is just a handy way of packaging stuff, if you don't know what containers are. And it has the exact copy of the national database.
Small question.
Sure.
Regarding the data, do you put it into the image, or do you use external storage provided of AWS?
Yeah, good question. The question was whether the data is in the image or is it separate. For a proper production system, it wouldn't be in the image. But in this case, this was a pilot project. There was a limited amount of municipalities working on a limited number of plans. It was just more simple to put it inside the container. But it had an exact copy of it, so it had the same sort of relational table. And what I didn't say about the Geospatial platform is that it gets the national format in XML in a complex feature, and then it breaks down into a relational table, like a classical SQL database. And we get a perfect copy of it, and then we run it on AWS. For GeoServer, like I mentioned, we have the data directory, the GeoServer configuration, app schema configuration, workspaces, data stores, all the basic things. If you know what GeoServer is, and as I mentioned, it builds every time someone makes changes to the configuration, so it's very handy. For the data formats, we use the app schema extension for GeoServer to produce the Inspire, all the complex features. And Hail Studio was used to then look at the relational database and map that into the PLU and into the national data model. There's some caveats in how app schema works. It's pretty nice, but there's some problems with if there's something which is required in the schema, it might cause a problem if the relational tables don't require it. And this is something which we've given feedback to the National Data Platform for how things should work in a case like this, where everyone where there is a strict format and you want everyone to adhere to that strict format, then it becomes slightly problematic because they are taking the approach that if it comes through the quality guard, then that's fine, but sometimes you want it to be very, very exact for things to work. As I mentioned, seamless updates. So deploy is very easy. It builds the new task with the new images, health checks work, and once the health check says everything is good, it switches it back. But the health check also means that it's very resilient. So we did some testing where we used our performance testing tools to purposefully kill the server, to make so many requests to the server that it just can't handle it. And this system automatically replaces the system with a new one. It just sees, okay, now it's dead. I bring up a new task, replace the task with a new one. And of course the task could be set up so that it's not just like at one task. You could say that it scales. If there's more traffic, it will just put more tasks together. There was the load balancer. We could have 100 of these tasks running on large servers at the point in time when there's a lot of load and there's a lot of need for the data. So this concept is very robust. We got the data update time to like less than 5 minutes. So when the file arrives into S3 from National Land Survey, under 5 minutes, the new data is up. It's not lightning fast. We could make it more fast, but this was enough for the purposes. The GeoServer was 20 minutes, mostly because we just made it so that it's actually building the whole GeoServer software just for fun. It could be faster, but this is how we did it this time. The conclusions, we found this to be a very robust system. This was like beyond what I expected. I sort of thought that, okay, we just need these really quickly. We can just build something really hackish, something really quick, and then have our monitoring tools make sure that it runs. And if something happens, then we're alert and we can fix it and sort of be dynamic about it. But actually, we were able to build a really nice way of publishing the open data on AWS. And using these like tool I said CloudFormation, that's very handy for this. It makes life very easy. Auto scaling is possible, like I mentioned. You could make this robust even under huge load conditions. So the key takeaway is like, don't think about if you can use cloud, more question yourself, why wouldn't you use the cloud? There's so great tools. If the data is open, there shouldn't be any reasons for GDPR or other compliance issues why you couldn't send the data into the cloud and host it there. And having this programmatic infrastructure makes life so much easier and so much more resilient to things than using like classical, here's a server, code something on it. Any questions? First one here.
I have two questions, but I'll wait for the second one. First question was regarding your infrastructure on AWS. You use the proprietary Amazon
Fargate.
Why not Kubernetes? It's a bit more. Make sure your infrastructure more mobile if you want to migrate to something else or local development.
The question was why we chose Fargate instead of like an open source or an open platform for this container fleet organization. I think the main reason in the end was just that we wanted to get things done quickly. We didn't want to add complexity on it. But on the other hand, you mentioned local development, and that's a key point here. Using the container registry, with the Amazon Container Registry, if there's a problem, any one of our developers can actually take the image from the container registry and run the exact same container on their own computer.
So the communication between the containers?
Fargate handles that as well. Or it configures that there's network connectivity between the containers. You can do that. I'm not exactly sure how that was done, but it's quite simple to do. Yeah. Okay. Roope in the back.
What's your roadmap for the future? Is it going to be an actual operational implementation?
Okay. So the question was this an actual operational piece of service. Yes, it's still running, but it's going to be taken down at the end of the year because this was only for a pilot project. The entire development cycle of the new legislation by the Ministry of Environment is still ongoing. We're heavily involved with it in other projects which have come after this, but we are still keeping these services alive for like demo purposes and so on for this year. But after that, the data model is proceeding forward. The data that is inside the database at the moment will not be relevant anymore once things move forward. So there's no real need to keep this running. And that's actually one of the simple things. We pay for this like 20 euros per month. That's it. So then we can just turn it off and no longer pay the 20 euros per month for it. But the concept lives on. And that's the more important thing. So this is something that can be duplicated, it can be used for other cases, and it can be used for production as well. Of course, it's now just built for the pilot, so making it robust enough for production does require a bit more work. There was
I have a question about granularity. So if you have, for example, 100 data sets, will you put them all into one GeoServer container, or will you have some 100 for each data set?
Yeah. So the question was granularity on is there one master GeoServer running all the data sets if there's 100 data sets? Most likely I wouldn't do that. I think in this case it makes more sense to run smaller instances, smaller GeoServers, because then also if you run into a case where there's a huge load on the server, it's most likely not going to be on all of the data sets. It's going to be on one data set or another. Then you can only scale those parts, so you don't have to affect everything. So it's probably going to end up cheaper. Giacomo?
Roughly, how long did it take to set up the pilot project, and roughly how many person-months you employed?
This was done in under almost about a month, but the basic setup was much quicker than that. Then there was like, when we got into actually doing the mapping of the data models and so on, then there was a lot of fiddling with that and figuring out so that it works perfectly. So I would say maybe half the time. And now that the concept is ready, setting up something like this is a few days. Yeah.
Regarding the building of the GeoServer, which took 20 minutes, did you incorporate a multi-stage Docker image?
The question was a multi-stage Docker image. No. It's just we just like build a Java server and then we just take a off-the-shelf Docker base container and put the server there. Yeah, exactly. Alexander?
Yes. So your input, if I understood correctly, is XML data that you download. You create a relational database out of that, and then in the end you recreate another XML or whatever.
Yes.
As an exchange format.
Yes.
I was wondering, you do that because you're not the provider yourself. You're tapping into the provider.
Yes.
I was wondering if NLS or some other provider is to be doing something similar. How much can it be optimized to not have to recreate from an exchange?
That's a very good point. We were working on the constraints of the project. So the question was about the fact that we were taking in XML that was transformed into a relational database and then transformed back into the XML. Yes, it doesn't make a lot of sense in my opinion as well. But the project was working in line with a Geospatial platform, and their concept is that data comes in through the upload service. It goes into this database, which is already a relational database. So it is then data is extracted from the complex data format or the GML into a relational database where it lives. And of course, it's much easier to do the lifecycle management that way. Or I would assume that it is. I think that's one of the reasons why they're working on it. But also, this is a generic platform, so it has to work for many other types of service or data sets as well. But for this particular service, it might make sense that the original XML would also be stored and that would be then used to serve. But then when you think about spatial plans, there's going to be one spatial plan, there's going to be another spatial plan, and then the third plan. And then the end result of the current official plan will be an amalgamation of these three. So you can't just simply take the XML that we got as an input and then give that out to someone. Of course it makes sense if someone really wants to see that particular spatial plan, but typically people want to see what is the current state of planning, you know, in an area. So that's where the data lifecycle management comes in, which harmonizes like the entire picture of the current planning. Roope?
You mentioned that currently you are paying something like $20 or whatever. But can you estimate, do you have any estimation that if you put all municipalities and real use load, how much it will cost?
Yeah, so the question is I mentioned something like 20 euros a month. What would happen if all of the planning data was in here, what the cost would be? I have no estimate for that. The database would be a lot larger. But on the other hand, it also, disk space nowadays is quite cheap for data like this. It's not like IoT data where it's gigabytes per day or terabytes per month, but that's pretty cheap. So that the real question is how much use there is. And then comes also the question, if the use is sporadic, that you have a lot of use on certain days of month, but mostly it's quite quiet, then using something which is scalable where you can predict the load, that you know that every Tuesday at 5 p.m. there's going to be a huge amount of requests, and you scale up before that, or create automation rules which make it scale up automatically before that. So then there comes also the savings, because you're not getting capacity, like fixed capacity for the peak load. Any more questions? Okay, thank you.